Okay, so today we're going to be doing section 2.7 of the geometry book called Proving Angle Pair Relationships. Now, earlier in the chapter, I have given you all a handout on some important theorems and postulates and properties that we have in chapter 2. I want you to turn to the side that has the right angle congruence theorem about halfway down the page. So here's some important theorems that we can use in geometry. So one of them is the right angles congruence theorem, and that states that all right angles are congruent. So if we know two things are right angles, we can use this theorem to say that they are congruent to each other. The next one is the congruent supplements theorem. So it says if two angles are supplementary to the same angle, or to congruent angles, then they are congruent. And then we have congruent complements theorem, which is the same thing for complementary angles. If two angles are complementary to the same angle, then they are congruent. So there's three congruent angle theorems that will help us in doing proofs and knowing when things are congruent and finding their measures. So here's the first example that we have of a proof involving these things. It has this are given, segment AB is perpendicular to segment BC, and segment DC is perpendicular to segment BC, and it has this figure over here drawn. All right, so we're going to prove that angle B and angle C are congruent to each other. So this one is actually a really simple proof if you use the properties and the theorems that I have given you. You're going to set up your two-column proof with statements and reasons, just like we will do all throughout this course. For everything we say, we have to prove it with a property or a theorem or a definition or something that can be given as a reason. So our given is segment AB is perpendicular to segment BC, and segment DC is perpendicular to BC, and that's given, segment BC. So both of those line segments are AB and CD are perpendicular to CB. It's running vertical against them in the figure. Prove that angle B is congruent to angle C. So this first thing was given. They told us that in the problem. All right, so I want to somehow prove that angle B and angle C are congruent. Well, by the definition of perpendicular, that's what that symbol means with that upside down T. That's perpendicular symbol that we should have memorized by now. The definition of perpendicular means that the lines or the segments intersect to form right angles. So if AB is perpendicular to BC, then that means this angle, angle B, is a right angle. And it also means that this angle C right here is also a right angle because it says DC is perpendicular to BC also. So I can say that angle B and angle C are right angles. And that is from the definition of perpendicular lines. All right, and since we just had a new theorem that says all right angles are congruent, and we have just shown that angle B and angle C are right angles, then I can say angle B is congruent to angle C because of the right angles congruence theorem. So that proof is done. I proved what I wanted to prove, which is that angle B was congruent to angle C, and I used the right angles congruence theorem that is on our handout to do that. All right. So the next one it gives me two things. Okay? So it told me, it didn't give me any kind of picture, but it told me that angle 1 and angle 2 are supplements. Remember, that means that they form together to make 180 degrees. And that angle 3 and angle 2 are supplements. All right? So that's my that's my first statement is my given. So I have statements and reasons, like I always do for a geometric proof. So there's my first two, angle 1 and angle 2, and angle 3 and angle 2 are supplementary. Well, if you look at your handout, the definition of the congruent supplements theorem says if two angles are supplementary to the same angle, then they are congruent. Well, angle 1 is supplementary to angle 2, and angle 3 is also supplementary to angle 2. So that means that their measures must be the same if they're both supplementary to the same angle. So angle 1 must be 3 based on the congruent supplements theorem. Now, had this been about complementary angles, then you would have used the same thing, except for you would have used the congruent complements theorem. Okay, so it's supplementary. The congruent complements and congruent supplements theorems work the same way. All right, one last congruence theorem we're going to talk about today are the vertical angles congruence theorem. Anytime we have vertical angles, they are congruent to each other. Now, we've kind of introduced vertical angles in Chapter 1. They are angles that are across from each other when two lines intersect. For example, from this figure, angle 1 is across from angle 2, so they are vertical angles. Likewise, angle 3 is across from angle 4, so they are also vertical angles. So, the vertical angles congruence theorem says that vertical angles are congruent. So, if angle 1 and angle 2 are vertical angles, then they're congruent to each other, and 3 and 4 are also congruent to each other. So, we can use that to help prove things and solve things and to find measures of angles. So, here's some practice on finding the measures of some angles. So it says the measure of angle 1 is 112 degrees. So I'm just going to label that right there. And if you look, angle 3 is a vertical angle to angle 1. So we know the measure of angle 3 is also 112 degrees. Okay. Well, we also can see that angle 1 and angle 2 form a linear pair. And things that form a linear pair are also supplementary. That means they sum together to make 180 degrees. So, if I want to find the measure of angle 2, it is supplementary to angle 1. So I can say 180 degrees minus 112 degrees. So the measure of angle 2 will be 68 degrees. And since that one is a vertical angle to angle 4, it would also be 68 degrees as well. So 2 and 4 are vertical angles. They should have the same measure. 1 and 3 are vertical angles, so they should have the same measure. So likewise, on number 4, it tells me that measure of angle 2 is 67 degrees. Well, that is a vertical angle with angle 4. So the measure of angle 4 is also 67 degrees. And it makes a linear pair with angle 1 and angle 3. So they're supplementary. So the measure of angle 1, for example, would be 180 minus 67 degrees, which is 113 degrees. And the measure of angle 3, since it's a vertical angle with angle 1, would also be 113 degrees. So linear pairs are supplementary. That means together they sum to be 180. Vertical angles are congruent. So the last one, measure of angle 4 is a vertical angle to angle 2. So angle 2 will also be 71 degrees. And angle 1 and angle 3 would be supplementary to 71 degrees, which means they would be 109 degrees. And measure of angle 3 is a vertical angle to angle 1, so it is also 109. So vertical angles are congruent. They have equal measures. So the last example I want to show you real quick in this lesson is how to solve equations using vertical angles. Now, since we know that vertical angles are congruent, we can set their measures equal to each other. So, for example, if I want to find x, I look for the angles that have x's in them, and that would be this one and this one. Well, those two are vertical angles. So I can say 8x plus 7 equals 9x minus 4. So since they're vertical angles, they're across from each other, then their measures are equal. So I can set those two expressions equal to each other, and now I can solve this equation for x. So I'm going to get my x's together, subtract 8x on each side, and I have 7 equals 1x minus 4. I'm going to add 4, and I'm getting x equals 11. Okay, and I'm going to do the same thing to get y. I'm going to do this in red. So I have 5y over here on the left, and on the right I have 7y minus 34. And those are vertical angles because they're across from each other from the intersecting lines. So I can set those equal to each other because vertical angles are congruent. They have equal measures. So 5y equals 7y minus 34. I'm going to subtract y on both sides to get my y's together, and I get negative 2y equals negative 34. And then I divide both sides by negative 2. So y is going to equal a positive 17. So that is how we can use our congruence theorems, and for right angles, congruent complements, congruent supplements, and then also vertical angle congruence. Have a good day.